Kr, that is renal elimination rate constant in uremic patient, is directly proportional to the product of a constant and creatinine clearance. Okay, this alpha, it is a constant, and this thing to that is creatinine clearance. Next, Ku, that is elimination rate constant in uremic patient, it is a sum of the non-renal elimination rate constant and renal elimination rate constant. So you can rewrite this equation as Ku equals to KNR plus, instead of Kr we can write the above equation, that is alpha, that is constant, multiplied by a creatinine clearance. So basically this equation can be used in the construction of a nomogram. So this is the equation and this one is a nomogram. In this nomogram, you can see on the x-axis is the creatinine clearance in ml per minute. That reflects the renal clearance. Okay, Kr equals to alpha into creatinine clearance. And on the x-axis, you can see uremic elimination rate constant in percentage Ku, which is a sum of non-renal and renal elimination rate constant. Next, apart from this, you can see drug A, drug B, drug C and drug D. 4 different drugs, each with different renal excretion rate constant. Now you can check out a pink box. The first point is the fraction of drug excreted unchanged in urine, that is Fe. Fe is a term for fraction of drug excreted unchanged in urine. For drug A, B, C and D are 5%, 50%, 75%, 90% respectively. Okay. So unchanged fraction means in urine means it is renal excretion. So this much amount of drug is excreted via the renal route. Okay. So drug A is 5% excreted via renal route. Drug B is excreted 50% via renal route. Drug C is excreted 75% via renal route and drug D is excreted 90% via the renal route. Next, the creatinine clearance of 80 ml per minute equals to or more than 80 ml per minute is considered an adequate GFR in subjects with normal renal function. See, the uremic elimination rate constant, that is Ku, is the sum of non-renal and renal elimination rate constant. Okay. KNR, that is non-renal elimination rate constant, remains same as that of the normal person. But in uremic person, Kr, that is renal elimination rate constant, decreases, because of which Ku, that is the uremic elimination rate constant, also decreases. Next, if the patient has a complete renal shutdown, that is when the creatinine clearance is equal to 0 ml per minute, then the intercept on the y-axis represents the percent of drug eliminated due to non-renal drug elimination route. Okay, so obviously when creatinine clearance is equals to 0, then the renal elimination rate constant equals to a constant multiplied by creatinine clearance. But creatinine clearance is 0, then Kr completely is 0. So elimination rate constant in uremic patient is equals to elimination rate constant for non-renal as well as for renal route. Okay, it is a sum of non-renal and renal elimination rate constant. But the value of Kr we got 0. Therefore, you can write Ku is equals to KNR. Next, as you can see over here, drug A is 5% renal elimination. Okay, so 5% of drug A is eliminated via renal route. That implies that 95% of drug A is eliminated via the non-renal route. Okay, so drug A is 95% eliminated via non-renal route, and you can see over here KNR is equals to Ku. So that's why the drug A is over here. Okay, 95%. Similarly, drug B is eliminated 50% via renal route. That means 50% eliminated via non-renal route, and non-renal elimination rate constant is equals to the total elimination rate constant in a uremic patient. So you can find the drug B 50%. Similarly, drug C is eliminated to 75% via renal route. That means 25% is eliminated via non-renal route, and Ku equals to KNR. Therefore,